this session is of class 11th. Okay. The chapter is mole concept. In last demo session, we started with masses, out of which we did atomic mass, molecular mass, empirical mass, and equivalent mass. Today we are going to study about average mass. Hope you guys remember this, right? Now let's start with average mass. Okay, what is average mass? What kind of mass is this? See, in nature, there are different type of atoms. For example, if we take an example of chlorine, in nature, there are two types of chlorine based upon isotopes. There is chlorine 35 and there is chlorine 37. In nature, the abundance of chlorine 35 is almost 75%, whereas chlorine 37 is almost 25%. Therefore, when we calculate atomic mass, the atomic mass is the average of masses of all the isotopes present in nature. Therefore, if you calculate average mass or average atomic mass, then it would come 35, that is mass number, into its percentage, that is 75%, plus isotope 37 into 25 upon 100. When you solve this, you will get 35.5. Now, this 35.5 is the average atomic mass of chlorine, which you will usually see in periodic table, the atomic mass of chlorine. Similarly, for other elements, you can also calculate. See, these type of questions usually come in NEET. So let's take an example of NEET question, right? Okay, I have told you the example. Now you will have to calculate this question number 4. An element X has the following isotope composition. Mass number is 200, having an abundance of 90%. Mass number 199 having an abundance of 8%, and mass number 202 has abundance of 2. Okay, so let's try to calculate the average atomic mass of X. So I told you the formula. What is the formula? You have to multiply mass number with its percentage and then divide it by 100. So average atomic mass will be equals to, the mass number is 200, percentage 90%. So 200 into 90 plus 199 into 8%. 199 into 8% plus, next is 202 into 2%. 202 into 2% divided by 100. Calculate this and tell me the answer. I hope all of you are getting my point. Please say yes or no in chat box. What is the answer? Okay. So there is an option of 201, 202, 199 and 200. So I'm smart enough to see this question that 90% abundance is of 200. Therefore, I'm not going to calculate this because I'm going with, yes, Sandipani, you are absolutely right. I'm directly going with the answer 200. Why? Because the abundance is in nature of X200 is 90%. So most probably my average value will come near 200. Therefore, 200 AMU will be the answer. Everybody got it or not? Say yes or no, please. Good. Now, let's try one more example. So, the question of average mass you won't be saying in JEE because that is too simple for JEE, and actually it is a club question. They are going to ask more detail about the average mass. So we'll go on to that question later. I hope everybody is able to see. Try yourself. Question number 15. Question number 15 and question number 16. Let's have a quick practice on these two questions. Boron has two isotopes, B10 and B11. The average mass of boron is found to be 10.80. Calculate percentage abundance of these isotopes. So just assume that B10 percentage is X. So B11 will be 100 minus X. So you know the percentage now. Now substitute in the formula, that is average mass is equals to percentage into mass number, that is 10, plus 100 minus X into 11 upon 100. Average mass is 10.8. Quickly calculate the value of X. After solving this question, you have to move on 16th question and let me know the answer. So Mahesh said X is 20. Okay. Let everyone solve. Then we'll see. Fine. B10 20%. Now this is the correct way of giving answer. Good, Mahesh. Those who had solved 15th question can move on to 16th question. Okay. For those who didn't attempted this question and was not able to do question, let me solve this for you. So in the given question, the average mass was 10.8 is equals to, we considered X percentage of B10 and 100 minus X considered for B11 divided by 100. So 1080 is equals to 10x plus 1100 minus 11x, right? So 1080 is equals to 1100 minus x, or x is equals to 1100 minus 1080, that is 20. So x is 20%. Therefore 100 minus x will be 80%. B10 is 20%, whereas B11 comes to be 80%. I hope everybody is getting this question. Okay, I got an answer from Sandipani for question number 15. So question number 16 is your homework, okay? If you have solved, let me know the answer in chat box. We'll move to next question. Okay then. Now, our next topic. Now, our next topic would be simple mole concept. What is mole? Mole is a unit. Like how we say in 1 dozen, there are 12 quantities. Like it could be 12 pens, 12 eggs, 12 bananas, etc. Similarly, when we talk about 1 mole, there are 6.022 into 10 to the power 23. Either it would be atoms or molecules or ions. Okay. Now this number is known as Avogadro's number and it is represented as Na or N naught or L. Okay. Now the symbol L is used for Perrin scientist. Actually, Perrin was the person who discovered this number and he dedicated this number to Avogadro. He was student of Avogadro, therefore this number is popularly known as Avogadro's number. Okay, always remember 6.022 into 10 to the power 23 atoms will always be measured in grams. For example, if you had taken 6.022 into 10 to the power 23 oxygen atom, then the mass will be 16 gram. If you had taken 6.022 into 10 to the power 23 nitrogen atoms, then it will weigh 14 grams. In all, we can say that Avogadro's number is equivalent to gram atomic mass or gram molecular mass. For example, if we took 6.022 into 10 to the power 23 H2SO4 molecule, then it would weigh 98 grams. Okay, now coming to next point, there are certain relations. This is a simple chart of mole. Okay, there is a mole and mass relation. There is a mole and volume relation. There is mole and number relation. Okay, first let's discuss about mole and mass relation. Mole is equals to given mass should be always in grams, upon gram molecular mass or gram atomic mass. For example, if we have 4.4 gram of CO2, then what will be the moles? So mole will be, what is the given mass? 4.4. That is 4.4 upon, what is the molecular mass of CO2? Carbon is 12 plus oxygen is 16. There are 2 oxygen, that is why into 2. So you will get 44. So 4.4 divided by 44, that is 0.1. So this is the simple example. Simple formula, mole is equals to given mass upon gram molecular mass or gram atomic mass. Now, if moles are given, and you have to calculate mass, then what you are going to do? Again, you know the formula. Mole is equals to given mass upon gram molecular mass or gram atomic mass. Just multiply mole with gram molecular mass or gram atomic mass, you will get given mass. For example, what would 0.1 mole of CO2 will be. So 0.1 is equals to given mass को आप you can write it as x upon gram molecular mass of CO2 is 44. Your answer will be 4.4 grams. Therefore, we can say that if mass is given, you have to calculate mole, then you can divide mass by gram molecular mass or gram atomic mass. If mole is given and you have to calculate mass, just multiply mole by gram molecular mass or gram atomic mass. Now, moving on to next relation, that is mole and volume. 1 mole 1 mole of any gas of any gas at STP occupies 22.4 liter. Therefore, 5 mole will occupy 5 into 22.4 liter. 10 moles will occupy 10 into 22.4 liter. So just what you are going to do? Multiply mole by 22.4. You will get volume of the gas. It is as simple as that. If you want to calculate mole, then what you are going to do? Mole is equals to volume of the gas upon 22.4 liters. Always remember, you have to use liter as a unit. Okay. So in this graph, we can say that if mole is given and you have to calculate volume, just multiply mole by 22.4 liter. And volume is given and you have to calculate mole, then divide volume by 22.4 liter. Here I had written STP. STP is standard temperature pressure. That is, temperature is 25 degrees Celsius and pressure is 180. This is considered as STP. I hope everyone is getting my point. Now let's do some practice on this. Calculate moles of the following. I'm gradually going to increase the level. Okay. Right now I'm just giving you a quick revision of how you solved mole concept in class 9th. Okay, then we'll move on to how it is going to be solved in class 11. After that, how it is going to be solved for NEET and then for JEE. So please be patient. Okay, calculate moles of the following. First, 4.9 gram of H2SO4. Second, 5.85 gram of NaCl. Third, 100 kg of calcium carbonate. Fourth, 1400 gram of nitrogen. And fifth would be, let's take an example of which would be your favorite one? I guess NaOH. So 4 gram of NaOH, because this is my favorite. Okay. Quickly calculate moles. Okay. Let's start. For H2SO4. Okay. So given mass is 4.9 divided by molecular mass of H2SO4 is 98. Okay, so this would be 0.1 by 2. 0.1 by 2, that would be 0.05. So first answer is 0.05. Next, for second, 5.85 divided by molecular mass of NaCl is 58.5. That is 0.1. Now this is 100 kg. You have to convert 100 kgs into gram. That would be 100 into 10 to the power 3 upon molecular mass of calcium carbonate is 100. This comes to be 10 to the power 3 moles. Now 1400 grams of N2 divided by 28. That is 100 by 2, which is 50. Okay. Now 4 gram of NaOH, that is 4 by 40. That is 1 by 10. So some had done calculation mistake. So kindly look into it. Don't try to rush into things. Just solve slowly but correctly. Okay. The formula is as simple as that: given mass upon molecular mass. That's it. If you are having problem in calculating molecular mass, please let me know. I'll tell you the atomic masses. Okay, let's move to next question. That is, calculate volume of the following. First, 1 mole of CO2. Second, 0.003 mole of H2. Third, 10 to the power 5 moles of NH3. Fourth, 1 upon 10 mole of PCl5. Fifth, 0.05 mole of ozone. You know the formula? What is the formula? 1 mole occupies 22.4 liters. Any answers? Okay, I got first answer from KP. That is correct. Right? Second is absolutely right. Nice, Mahesh. Next, third, fourth, and fifth are still remaining. Mahesh, that would be 0.067. 0.0672. There is a calculation mistake at your end. Okay. 2 to 4, and there are 4 zeros, right? Okay. So 22.4 into 10 to the power 5 liters. Yes. One student is quite quick, that is KP. Where is everyone else? Only Mahesh and KP are answering. Where are the others? Last one is remaining, 0.05 mole of ozone. Yes, absolutely right, 1.12 liters. Good, Mahesh and KP. Now, Let's move to next, that is relation between mass, mole and volume. So need aspirants, this is the section where your question is going to come. Okay, mass, mole and volume. If mass is given, first calculate mole, and then from mole you can move on to volume. Similarly, if volume is given, first calculate moles and then move on to mass. For example, if you have given 4.4 gram of CO2 will occupy what volume? What volume? So how you are going to proceed? From the mass, you will first move to moles, and after moles, you are going to move to volume. Okay. So let's calculate moles first. That is given mass, that is 4.4 upon molecular mass of CO2 is 44, which will come 0.1. And from mole to volume, you know how to calculate volume? You have to multiply by 22.4. So volume will be 0.1 into 22.4, which would be 2.24 liters. So from mass to mole, mass divided by gram molecular mass or gram atomic mass. From mole to volume, just multiply mole by 22 point. Okay. So answer is 2.24 liter. Okay. If volume is given, for example, you have given a volume of 22.4 liter of H2 will have what mass? What mass? Then what you are going to do? Volume is given, you have to calculate mole first. So divide volume by 22.4, you will get mole, and after getting mole, you just multiply it by gram molecular mass. You will get mass. So 22.4 divided by 22.4 will be 1. 1 is the number of mole. Therefore, mass will be 1 into gram molecular mass of hydrogen is 2. So 1 into 2, that is 2 grams. So answer is 2 grams. All good? So these two questions is done by me. Our next two questions you guys will be doing. Calculate volume occupied by 7.1 gram of chlorine gas. First question. Second, what will be the mass of 134.4 liter of hydrogen? To help you out, atomic mass of chlorine is 35.5. KP has already given answer. I got answer from Sandeepani too. That is Sandeepani. You have answered for question first or second? First. You need to check your answer again. Okay. So for calculating volume from mass, first calculate mole. So mole will be given mass, that is 7.1, divided by 71 is the molecular mass of Cl2, which would be 0.1. And for volume, what do you have to do? 0.1 into 22.4, that is 2.24 liters. All good? Those who had made mistake, kindly check again. Okay. Now, for second, volume is given. So mole will be volume divided by 22.4. That is 134.4 divided by 22.4, which is 6. 6 is the mole. Now you have to calculate mass. So for mass, we know mole is equals to given mass upon molar mass. So moles are 6 is equals to X is the given mass upon molecular mass of hydrogen is 2. So answer will be 12 grams. So Kp, did you see your mistake? Yes. Okay, now next we are going to move on mole and number. This, if you multiply mole by Na, you will get number, and if number is given, just divide it by Na, you will get mole. For example, calculate number of molecules in 5 moles of H2O. So what you are going to do, mole is given, therefore number of H2O molecule will be 5 into Na. Simple. Now, to increase its trickiness, what I'm going to ask you is calculate total number of atoms in 5 mole of H2O. I'm asking about atoms, and you are given moles of water molecule. So first calculate number of molecules. The number of molecules will be 5 into Na. See, Mahesh, you don't have to calculate atomic masses, okay? As you will get used to of it, you will remember all the atomic masses. Okay, for example, if you have any questions like you don't know about the atomic mass, just ask me. Okay, as you do practice, you will learn all the atomic masses. It is still new for you. Okay, so don't worry about it. Slow is good. So number of molecule will be 5 into N. In one H2O molecule, there are how many atoms? 2 hydrogen atoms and 1 oxygen atom. Therefore, there are 3 atoms in one water molecule. You have 5 into Na molecules. Therefore, total atoms will be 5 into Na, that is total number of molecules, into 3. This will give you total number of atoms. That is 15 Na is your final answer. I'm going to explain this again. Okay. In first part, I just asked you what will be the total number of molecules in 5 mole. So what I did, I was given water molecule. So what I did is I multiplied 5 mole by Na. Okay, so 5 into Na will give me my number of water molecule. In second part, I told you to calculate total number of atoms. I had given you about water molecule, but asking about atoms. So first, what you are going to do, you are going to calculate number of molecules first. The number of molecules will be 5 into N. And as you can see, there are 2 hydrogen atoms and 1 oxygen atom, which will give you 3 atoms in one molecule. So if you are having this many number of molecules, the total atoms will be 5 into N into 3, that is 15 N. Please let me know if you want this explanation again. Okay, no? Okay, let's try one question. Calculate total number of atoms, total number of oxygen atoms, total number of sulfur atoms, total number of hydrogen atoms in 5 mole of H2SO4. You have to calculate total number of atoms, total number of oxygen atoms, total number of sulfur atoms, and total number of hydrogen atoms in 5 mole of H2SO4. No, keeping Na spin. Why are you asking about sodium? Okay, you are telling me the answer. Okay, 35 Na. I don't think so. This is correct. Kp. Kp has given me an answer of 35 Na. Huh. Okay, you are telling me about total number of atoms, right? Yes, 35 Na is correct. So everyone, Kp is very quick in this. Okay. I have given you about molecules. So first calculate number of molecules. So number of H2SO4 molecules will be 5 into Na. Now for oxygen atom. There are 4 oxygen atom in one H2SO4 molecule. If we have this many molecules, then you will have 5 into 4 into Na. That is 20 Na. So oxygen atom will be 20 Na. Next is sulfur atom. There is one sulfur atom. You have this many molecules. That is 1 into N. So Na is for sulfur. Now for hydrogen atom, there are 2 hydrogen atoms, right? Therefore, for hydrogen atom, 2 into 5 Na. That is 10 Na. For total number of atoms, see how many atoms are present in one H2SO4 molecule? 4 oxygen, 1 sulfur, and 2 hydrogen. Therefore, there are total 7 atoms, right? So total number of atoms, total atoms will be 7 into 5 into n. That is 35 n. I hope everyone is clear in this. KP, how you got hydrogen atoms as 20 n? By mistake. Okay, fine. Okay, now let's move on to some JEE mains level. Okay, that would be mass, mole, and number relation. If mass is given, you have to calculate mole first. That is by dividing it by gram molecular mass, you will get mole, and just multiply mole by Na, you will get number. If number is given, divide number by Na, you will get moles, and when you have to calculate mass, just multiply moles by gram molecular mass, you will get mass. Okay. Now, for example, you have given 4.2 gram of 4.2 gram of N3 minus, and you have to calculate total number of valence electron. So I just moved you to JEE mains level. Okay. So you have given mass and you have been asked about number. So first mass to mole and then mole to number. So moles will be given mass, that is 4.2 upon N3 minus molar mass is 42. That is 0.1 moles. Okay. Now, number of N3 minus ions would be 0.1 into N. Nitrogen has 5 valence electrons. There are 3 nitrogen atoms. Therefore, in N3 minus, there would be 15 valence electron plus 1 negative charge is there, that is 1. Therefore, total is 16 electrons in its valence shell. Therefore, total number of valence electron would be 16 into 0.1 into N. So your answer would be 1.6 N. I hope this question is clear to everyone. I'm again going to repeat this. You have given 4.2 gram of N3 minus and you have been asked to calculate total number of valence electron. Okay, in nitrogen atom there are 5 valence electron. So total valence electron in N3 will be 15 plus 1 negative charge is there. For 1 negative charge we add 1 electron. Therefore total electron is 16 electrons. First we calculated moles. Moles is 4.2 divided by 42, that is 0.12. And after finding mole, we had calculated number of N3 minus ion, that is 0.1 into N. Now for valence electron, in one N3 minus ion, there are 16 electrons. So if we have this many N3 minus ion, then total valence electron would be 16 into 0.1 into N, that is 1.6 into N. So this is our final answer. Mahesh, okay, I just repeated this again. Okay, I'll explain this again. Just try to understand, okay? See, in this question, this is one ion, single ion, okay? 4.2 gram of N3 minus is given to you. First, calculate moles of this. So 4.2 divided by 42, there are 3 nitrogen, therefore 3 into 14, which will come 42. Okay, so molar mass will be 42. So 4.2 divided by 42 is 0.1. Now, in one nitrogen atom, there are 5 valence electrons. So, the molecule is made up of 3 nitrogen atoms. So, total valence electron will be 15. And there is 1 negative charge in these 3. So, plus 1. So, total valence electron is 16 electrons. After calculating moles, we just calculated number of N3 minus, that is 0.1 into N. Okay, in one N3 minus there are 16 valence electrons. So if we have this many N3 minus ions, you will get 16 into 0.1 into Na valence electron, that is 1.6 Na. I'll give you a question to solve this again, so you will get a practice on this. Okay, fine, Mahesh understood the question. Okay, now try to solve this question. 6 gram of carbonate contains how many electrons? How many electrons? Or calculate total number of electrons in 6 gram of carbonate ion. You can start to solve this question. Atomic mass, okay. Carbon 12, oxygen 16. Okay, everybody, first tell me what is the moles of 6 gram. Moles is 6 by 60. That is 0.1, right? In carbon, there is 6 electrons. In oxygen, there is 8 electrons. And for 2 negative charges, there is 2 electrons. So total electrons are 16 electrons. So in one carbonate ion, there are 16 electrons. Okay, so we had calculated moles. Now, number of carbonate ions. Sorry, just multiply by 3 also. So answer is 32. This is 32 electrons. 32 electrons. So number of carbonate molecules will be 0.1 into Na. Now total electrons will be 0.1 into 32 into Na. That is 3.2 N. This is the answer. I hope everyone understood this problem. Okay, so KP already told me the correct answer. Very good, KP. Okay, so let's do one objective question. Question number 42. I want everyone to solve question number 42. D is for deuterium, okay? Deuterium. Deuterium has a mass of 2 and electron is 1. Deuterium contains 1 electron and it has a mass of 2. Hydrogen has a mass of 1 and electron 1. I'm waiting for your answers. So KP got the correct answer. I'm waiting for others too. Okay, Mahesh also got the correct answer. Very good. So how you are going to solve? Mass is given. First calculate moles. So moles of D2O will be 2 by 20. That is 0.1. And moles of H2O will be 1.8 by 18, which is 0.1. In oxygen, there are 8 electrons. Okay. Therefore, D2O will have 10 electrons and H2O will also have 10 electrons. So if you multiply 0.1 into 10 into Na will be total electron in D2O and 0.1 into Na into H2O will be total electron in H2O. So the answer is coming same. So correct answer is option 2, which is same. Now this question number 43 is your homework. Try to solve this question. Okay. All right. So I hope everybody has copied this question. Now I am going to end this session. Those who have any query, they can send me message on Zoom only and let me know your feedbacks. Okay. And please revise all the formulas which we had studied today because this is very important. This is the basic concept and this is going to be frequently used in chemistry. Okay. So I'm just signing off you guys. Okay. Thank you so much.
Thank you, ma'am.